Welcome to SUSECON 2022 and our session, Improving the Developer Experience of Kubernetes. Today, we're going to talk about what is developer experience and why you should care, the two paths about improving developer experience, the first path being improved tooling, and the second path being different developer abstractions. My name is Andrew Gracey, and I am on the product management team here at SUSE and Rancher, and I'll let Matt introduce himself.
And hi, I'm Matt Farina. I'm a distinguished engineer working over on Rancher and the suite of software that we produce from that business unit.
So first up, what is developer experience? So you've probably seen this stack shown quite a few times at SUSECON at this point. But this stack kind of tops out as SUSE Rancher itself. And kind of begs the question of where does the software that we're going to be installing and running on the stack come from? Um, this stack, basically, the software that would run on the stack is obviously going to be built by developers at your organization. And to do that, for them to do that the most effective way possible, they need the best developer experience that they can get.
And when you take this stack and you start to look at what goes on top of it, where is the developer tooling? It turns out there's a lot of tooling that developers bring to the table. In fact, a lot of times there's a lot more tooling than our simple stack. The images you see up here are a fraction of the developer tooling that you can find over on the CNCF landscape. And this is just a fraction of all of the different projects that are out there. And these aren't their applications. These are the tools that they bring along to help them write applications and to help them run applications so they don't have to interact with, well, all that Kubernetes complexity. And let's be honest here. There's a lot of complexity that developers have to deal with these days. I just showed you a screen with a lot of different applications that can be in the loop to help them with complexity. This graph right here is one of those components that we SUSE ship that comes out of the CNCF community. And this is one of the microservices dependency graphs. And you can see there's a lot of dependencies. And when you start just looking at everything that developers have going on, there's just so many things they have to navigate that deals with their business logic, the dependencies they're getting to help them with their business logic. And that's really where they want their focus to be. So the tools and the complexity that they have to go manage, there's a lot going on there above and beyond what's already brought to the table on the infrastructure side of things.
So the world has changed for developers in the last probably 5 years or so. At this point, developers are now responsible for feature changes of the business logic itself and the application that they're building. They're now responsible for large chunks of the operational logic, security of their applications and the infrastructure that it's going to be running on, and keeping up with new libraries and frameworks. Um, with that, due to the historical legacy of what developers have traditionally been taught, but also just a needed separation of concerns, developers tend to be less good at operations and security. There are a variety of reasons for this, but the main one is that developers typically become developers because they want to build interesting things, move fast, and kind of stay on the cutting edge. Um, and so this addition of all of this of the additional responsibility really just kind of works to slow their velocity and of features that they're actually able to build.
And when you look at the developers in general, right, you've got to take in who they are and their context. And I think that's really important to know who they are and where they're at. Because developers who are working on those applications, business logic, they're not operations. They're not professional security people. They have their area in the separation of concerns. And on top of that, they're also heavily inexperienced in the grand scheme of many years of things, right? If you think of, other fields where people have been around 20 or 30 or 40 years doing something, a lot of software developers are really young. In fact, about half have had about 10 years or less of professional experience. And so as they're learning the languages, as they're learning about how to write good APIs, how to make libraries and do separations of concerns there, they also now in the Kubernetes space have to deal with, how do I operate this thing? And what are all the complexities that go on there? And so the experience and the amount they have to learn in that time where they're learning and gaining experience is just a lot.
Yeah, and I'll throw out that one of the good things of the modern trend is that the barrier of entry to being a developer is getting lower. And this is a very good thing because we do want more people to be able to become software developers and to be able to have their voice heard in this community. So there's a lot of positive benefits to the fact that we are getting more people into the industry and more diversity into the industry. There are so many downstream effects of this that are all positive, right? But another downstream effect is that we do have this relatively inexperienced uh, population of new developers, right? And so it's up to us to give them the best tools and to give them the best processes to do their job well and to learn more, right? So developers kind of work at all of the software development life cycle is the cycles of cycles, right? Everything is iterations. So you have your inner loop, and this should really be 5 seconds to 5 minutes, kind of at the high end. This is where you're doing your quick iterations of editing code, potentially researching how new features might work if you're like looking at like building a loop and optimizing and kind of what, especially if you're like on the user experience side, feeling out how certain features feel to an end user. You really want a very quick turnaround with fast failures and as few manual steps as possible. Moving out a little bit, once you get to a point where you're actually happy to check into Git, you would kick off a CI pipeline. This should do automated testing, automated builds, hopefully some level of code review, auditing, security analysis, that type of thing. You move from that CI cycle, and say things fail in CI, you go right back to your inner loop and start that cycle again. Once CI passes, you move on to some testing, where you should be doing some holistic testing. You should be really looking at security, and hopefully most of this should be automated, or at least as much as possible should be automated. Once everything passes your testing, you move on to production, where the major concerns there are how easy it is to operate. Can you observe what's going on so that you can get that data? If an error happens in production, can you get that data back to the developers in a meaningful way? And really, yeah, can you bridge that gap from what is seen in production back to developers so that they can fix it hopefully quickly, or at least reproduce the issue in their own environment? As we kind of move between these cycles, the ownership kind of moves from the developers on the inner cycle to operations, the operations team, obviously working in production. And the responsibility of that, um, for the inner loop is typically a single person, maybe a team if you're doing mob programming, which is an amazing practice, to on the far right side, the responsibility should be owned or shared by the entire department at that point. You should have developers, security, operations, docs, QA. Everybody is responsible for things in the right hand side. So you kind of like have this shifting responsibility as you go through. And so we need tooling for that.
And one thing to keep in mind here for the developers, continuing the looking at context, is that Kubernetes isn't just hard, it's very hard. And to illustrate this, I bring up two things. One, a handful of versions ago of Kubernetes, somebody took the Kubernetes API documentation. This doesn't explain how to use Kubernetes. It doesn't explain the right way to do things or processes. It very simply says, here is the API, which you put in and the responses you get. They turned it into a book, and it was about 684 pages. About two-thirds of this API is something that you might use in operating your workloads. That's a tremendously large API with a lot of complexity, especially when it's not telling you how to use any of it. There's no examples, no how to, no guidance. That's all above and beyond it. And there's a lot there. In fact, the training course out of the Linux Foundation, where the CNCF is part of, that's the free training course for developers. I'm sorry, it's not free. It's 35 hours long, and it only handles a fraction of the scenarios, right? It handles dealing with a stateless deployment, but if you're going to get into stateful workloads or anything complicated, it's not there. And really, this kind of training to onboard, if you're going to use Kubernetes, is the basics that every developer would need. And this really doesn't scale up well. So if you've got an organization that has hundreds of developers working on an application, now hundreds of developers would need this 35-hour training that only handles a subset of the use cases and what you can do with the API that a lot of people go far beyond. And so there's so much complexity, you can't even contain it into small bits of training. um, and so Kubernetes is hard. And if you're a developer who's got to keep your business logic, your programming language in your head, and now you also have to know a bunch of stuff about Kubernetes to have in that mental context, there's just a lot there. And that makes Kubernetes difficult for developers.
And it also changes every 4 months.
And so, what is developer experience? I like this quote really struck to me that developer experience is about creating an environment in which a developer can do their best work. You really want to help them succeed. Don't make developers operations, but help them be incredibly successful while you still get the benefits of Kubernetes and everything else. So, how can we do that?
Well, first, we can eliminate unneeded complexity to give a better developer experience. And that's pretty much it. But that's not easy, right? There's so much that goes into that. So there's really kind of two paths or two schools of thought around how to go about this. Um, on the left here, we can give targeted abstractions that are very specific to developers, what they need, how they work. Um, this is the kind of Heroku, Google App Engine, Cloud Foundry, OpenFaz, and one of our projects that I'll talk about in a little bit later, Epinio. That's kind of what they do, right? They give you a very nice experience for the developer, but sometimes with the trade-off of flexibility, customizability, that uh, potentially operability, that type of thing. The other option is that you go down the route of making Kubernetes and container development more accessible. This is what Rancher Desktop does. Loft has some really cool tools around doing this. Telepresence is a cool tool. Scaffold. This route is what a lot of the ecosystem around Kubernetes has taken, and there's a lot of really there's a lot of really useful tools out there. But we need both types of abstractions. There are trade-offs to either, and so they're going to be appropriate in different places for different teams, depending on what you're wanting to do. If you're building simple apps with little configuration, you really probably want to look at a PaaS. You want to, with the tooling, you want to see how possible it is to customize and what actually comes out of the tool. Um, you probably are concerned uh, of convention over configuration, or maybe you want to go the other way, right? So you want to have these flexible opinions. But more importantly, um, one of the things that really drove DevOps kind of from the beginning was that like historically, developers kind of built their application, then just kind of threw some stuff over the wall over to operations, and didn't really have any consideration or really any insight into what it took to actually run their code in production and the constraints that production was under. Um, so we came up with DevOps. It's really talking. I mean, DevOps is coming out of theory of constraints and Toyota Production System, and kind of those historical avenues. The Phoenix Project is a fantastic book, and every developer and operator should probably read it because it has some amazing ideas and sets the stage for all of this. But the industry kind of shifted and went maybe a little too far to the other side and tore down the wall and left this kind of this empty field with a build it yourself approach. Um, what we really should have is a a chain link fence with a gate in the middle where you can see and you communicate with it with other roles. Like if you're a developer, you should know what operations is doing, what constraints they're under. You should be having conversations with them continuously, but there should still be some separation concerns. And especially because developers and operators have two different, typically are driven by different constraints and different concerns, and they butt heads in a very productive way, where if you have both teams working together, you end up with a better solution at the end because they're pushing each other to be better, right? So the first path that we're going to talk about is improving abstractions, and Matt's going to talk about the tooling that we have for that.
All right, so I want to start by talking about Rancher Desktop. Rancher Desktop is a desktop application that brings container management and Kubernetes right to you on the desktop. It gives those local tools that you may used to have in a cluster and things like that. It just makes them available for you in your working environment. And having these tools with easy access is really crucial for developers for things like that inner loop that we talked about before. Now, Rancher Desktop, I said, is a desktop application and it provides a bunch of features. It includes K3S, the lightweight Kubernetes distribution out of the box, and it lets you do things like set your Kubernetes version. And this is important because most people aren't using the latest version of Kubernetes. They're using one in their environment, and that environment you want to use, you want your developers to be able to work with, right? That same environment that's in production. And you can even, if you don't want to use Kubernetes, if you're just going to work with containers, you can actually disable it and just use container management. And here we actually let people use different container managers. You can use Containerd, which is the backend. It's very widely used as that backend used with Kubernetes. And if you want to use container commands with it, there's Nerdy control, which is a Docker CLI compatible-ish version. Or we have through the Moby project, Dockerd as a runtime, and the Docker CLI will work with that. Now, this application has a whole bunch of other things. You can do things like port forwarding your internal services from Kubernetes. You can do image scanning and stuff like that. But there's a lot packed into Rancher Desktop, and this is the settings screen that you can bring up along the way. Now, this platform runs on Windows, Mac, and Linux because we recognize developers' primary workstations, their primary environments where they're working on, are often Windows and then Mac. And then there's still a lot of people on Linux. So, how do we bring these tools to everybody in a fairly consistent manner so no matter where your developers are at, they have those tools they need? Now, this picture is a rough architecture diagram of Rancher Desktop. And so you've got Rancher Desktop as an application. And then on Mac and Linux, it uses a project called Lima to spin up a virtual machine. And it does everything inside that virtual machine. And then it'll spin up Containerd or Dockerd as the runtime, then K3S on top of it, and then make all of that available to those local tools, Nerdy control, Kube control, Helm, your CLI, your Docker CLI, and there's some other tools that are coming along the way that are included. How do you make that easily accessed and configured to just work? And on Windows, we've taken a different environment. Windows, modern Windows 10 and 11, has the Windows subsystem for Linux. And that literally spins up a Linux environment that Windows manages for you. And so in there, we spin up an environment with Containerd or Dockerd and then K3S. It's very similar to the Mac side. And we're using kind of what's the best native way in these environments for this to happen. And Rancher Desktop will manage that in the appropriate environment. Some other things that are included in Rancher Desktop are a dashboard where you can view what's going on in your local cluster. You can look at the workloads, the nodes, storage, whatever you have going on, you can navigate it. And this is the same dashboard that you get inside of Rancher, but instead of being targeted at your clusters you're managing under Rancher, it's now targeted just at that local environment. And it's that same dashboard. So as you learn to navigate one, it translates to the other. Now, real quick, just to talk about some of the design goals of Rancher Desktop, because we want to be clear about it, right? I've already talked about choosing the version you want. One of the things that goes along with the choosing the version, as you'll see on the right side here, is seamless upgrade. How can you test your applications when Kubernetes is upgraded so you can see what happens to them in that environment? So in Rancher Desktop, if you go into that version switcher and you choose a newer version of Kubernetes, it'll actually upgrade the environment to a newer version of Kubernetes, and your workloads will come up in that new version of Kubernetes. So you can see what happened. Testing can kind of be scary. Upgrading your Kubernetes environment can kind of be scary. And we want to make it a little bit easier to test workloads in that upgrade environment. And of course, we're leveraging upstream projects. We've got many different things from Container D to Docker D to K3s. Ranger Desktop brings together, it kind of integrates everything together while leveraging the power of these things you're probably already using or these well-supported off-the-shelf projects just to make sure that you get that environment. We're not trying to recreate the wheel, we're trying to create a better experience. Of course, there's easy installation. This installs on Windows, Mac, and Linux the way you'd expect a project to. On Mac, you download a DMG and drag it over. On Windows, there's a simple Windows installer. On Linux, you can install it with a package manager or app image. We're going for making it easy in that context. And of course, everything is completely open source. There is no hidden magic. You can go find the source code up on GitHub and look at everything. And then there's that container toolchain. A lot of what I've talked about so far is Kubernetes based, but we have that container toolchain because we realized along the way that people who were working with Kubernetes also wanted and needed to be able to work with containers, building, pushing, pulling images, that kind of thing. Maybe build an image, test it out inside of Kubernetes before ever pushing it to a registry. And that's entirely possible with Rancher Desktop. And one of the other nice things here is the integration with external tools. Here I've got a screenshot of Visual Studio Code running something inside of a dev container. And a dev container is where Visual Studio Code can talk to Docker D. It talks to the Docker socket over Docker D in order to have an environment running inside of there. And so here's source code mounted inside of a container. And whether somebody opens this up on Windows or Mac or Linux, they have the exact same environment. And it's Visual Studio Code working with and talking through the API integrations that you can get through Rancher Desktop. And so these external tools will work with it as well. And you can learn more about Rancher Desktop at rancherdesktop.io, or just go ahead and download it and try it out.
The other way to go about this is with better abstractions, or I should probably say more targeted abstractions. Um, with this, yeah, so I want to call out that Heroku and Cloud Foundry got a lot of things right. They have a very simple and short ramp up for developers, so you don't need a lot of additional knowledge about how things are working. You just push your code. You don't have to worry about the build artifacts. You really just push your code, and it builds it, it runs it, it deploys it, everything. You don't need to know anything about the infrastructure behind it. And lastly, you have a marketplace of services at your disposal. So you can actually say you need a Redis backend, for example. You can just spin one up, right, with a simple command. And again, you don't actually need to know how to run Redis or configure Redis. You have a sane, um, uh, again, back to separation of concern. You just get to say, hey, this application needs a Redis, and we're going to mount it in this way. Done. So we've built a tool called Apinio to do that. And this is our next generation platform as a service, and it kind of comes without all the fluff. Um, our design goals for this are really around the first and foremost, we need a great developer experience. Uh, Again, we like the single command push and the short learning curve. So again, you should be able to just browse to your uh, the directory of your code and push that code without any modification to it. We really wanted to have minimal complexity for two reasons. One, it allows us to develop more features faster, so we like that internally. But also for users and especially for platform operators, it reduces your mean time to recovery because there's one less things to break, and when things do break, there's less to have to dig through to figure out why. So you can get things back up and running significantly faster than if you have this really complex behemoth of a system. Um, we wanted to simply simplify the handoff between dev and ops. Again, back to that chain link fence with a gate. We kind of wanted to be the abstraction and kind of the boundary between the two teams so that they can work really nicely together and have those conversations around what's actually needed to make the whole process work better, specifically the human process, right? We needed to obviously provide a service marketplace that again dramatically simplifies the developer experience because you don't have to know how to administer a database, right? We need to make it easy to debug your applications that you're running uh, with this tool, especially during the inner loop. And then lastly, this needs to be Kubernetes native. Kubernetes is the de facto standard for building platforms at this point. And so we really wanted to leverage Kubernetes native objects to give a strong operator experience as well as the strong developer experience. Again, back to cycles of cycles. Um, Opinio can be used at different phases of the cycle depending on how you want to set it up. We're obviously targeting the inner loop, but if you set it up correctly, you can maintain that same tool chain between the inner loop CI testing and then production, depending on your specific needs. We do come with batteries included. All of these pieces are what we kind of ship with by default, but everything in here except for Kubernetes can be modified and customized to fit your specific needs, right? If you need a different build process for your application because of some compliance or governance restrictions, you can build your own builder image and we can help you do that. Uh, if you need different applications, we can change the Helm chart. And you can even give multiple classes of service to the applications to choose from for different potential application needs that they might be rolling out. If you want to have your S3 storage be somewhere other than the built-in MinIO, or if you want your container storage to be somewhere else than the local cluster, so that you can scan those again for security or regulatory compliance, you can do that. You can also offer different services, right? We come with a couple by default, just to again make the initial developer experience better, but you can customize it however you want. So if you want to get going with Apinio, it is apinio.io. And the instructions to install are relatively straightforward and can be found on that page. So definitely try out these tools. Let us know how they go. And then lastly, uh, join us on the Rainstor user Slack and have a conversation with us about what you would like to see, how you would like these projects to evolve in the future, or any potential issues that you find while trying it out. And we can definitely help you there. So thank you for joining our session.